Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire and today I've got Rens, who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation of that. So, as we always do, let me hand over the platform to him and then he can show us what he has managed to accomplish. Alright, whenever you're ready, Rens.
Thank you. Good afternoon, everyone, I guess. Not sure who's watching. Over the past few weeks, I've been working on the first project for robotics for this robotics course. I have some background in robotics actually, so it was a bit of recognition and a bit of new, so that was great. Do you want to start with a demo or first code review?
Let's start by showing what the code can do on the real robot. I believe you've got the slot reserved, right?
Yeah. Okay, so I think I can now, let me see, I can connect.
Okay.
All right, great. So I guess we have some connection with the robot. Yeah, sounds great. Oh, I ran it into the wall. So let's just do the demo. I will use the shell to access all the files I need. Actually, in the basic, I just use,
Alright. Can you
where is it
enlarge
again?
the robot stream window just a little bit so that we can see it better?
Yeah, oh, wait, that's not correct. I think I lost my.
It's on the antenna side.
Yeah.
Yeah. Okay.
Oh, I should not. Oh, wait. It's a bit clumsy, sorry. Okay, so here first I have this one, and I have this one. Okay, and I have to find two terminals, and I have to run two scripts at the same time. So first one is robot interface, which actually connects, I think, the sensor data to maybe Linux. I'm not totally sure, but this is connecting me with ROS, I think. And then we have the, let me see what this thing was called again, obstacle avoider script, which is actually the bash file that performs the sensor commands to the robot. And what does it do? Tries to make sure that the robot does not run into the wall. So we're now starting. This one should be ready. Okay, so it's measuring. Yeah, it's measuring all sides.
Did you start it facing the wall intentionally, or that was unintentional?
No, it wasn't intentional.
Alright.
But should work anyway. Yeah, so what it does is it kind of logs what is it's doing. That I also had to use for debugging, of course, because it was not the first time right. This script was quite some hassle to make sure that it doesn't run into any error. Let's say. yeah, that's it, kinda. Um, so that is this script working at least. I think I can now. I should not. I don't have a nice exit script, if I'm correct. No, I don't have a nice exit script. So if I exit at the wrong time, then I guess I don't. It will run into the wall at some point,
Oh,
maybe.
okay. All right, I see. Okay, so can you did you also implement an obstacle avoidance? I mean, a statistics script?
Yeah, the statistic scripts I did as well, but
You need
it
the
was
obstacle avoider to
yeah,
be
it was
running.
not very interesting. I was a bit lazy in that regard. Didn't have doesn't really have a lot of logic in my so yeah, I did it very lazy.
So
um,
we okay. So what you wanna do is, since it's running, can you also run the obstacle avoider script so that we
yeah,
see that
I would
this
have
one
to.
updates accordingly?
Yeah, yeah, I will just do this one, and then I will see. So I think now it's not. It's a bit stuck, isn't it?
Mm,
So the logic is not flawless.
let's wait for it. Is it updating now?
It
Yeah,
is
it did.
changing,
Yeah.
but I did not really.
Yeah, but the values are not changing there. Well, only I can only see that one. Yes, that's the one that's changing.
Uh,
Can you open the script so we can see it?
yeah, so the script is a bit lazy. I can show it to you. I think it's kind of changing, right? But it was only standing on the same place at the
Oh, so
like
the
at the
year
start.
was the only one that was changing. Yeah.
Yeah, so the first one is like I think the odometer, like how far it has moved,
Mm-hmm.
and well, at the start it was only turning, so I guess in that case it wouldn't. So now it reads 144.
Mm-hmm.
So, but I can show you the script. It's not. I can show you it. So yeah, I was not very into this assignment. This wasn't my thing, and I couldn't. I'm not sure. Maybe I assumed this was a mistake in the course, but these sensors I didn't get,
For the IM, yeah,
did
yeah,
I?
yeah. No, yeah, you're not getting those ones for this particular robot, so you are right.
No, exactly.
Yeah.
Okay, so that's that. I shall quit
Or all right.
this
So
one.
yes. So what I want you to do is to now uh, at least take us step by step through the obstacle avoidance script.
Yeah, that is the interesting one, right?
Yeah.
Okay, so it was a bit clunky programming in this in this Bash script style,
All right.
but
Can you
I
enlarge
basically
that a bit?
follow. Sorry,
Yeah, can you?
large. Yeah,
Yeah, enlarge it a bit. So
yeah. If only I could. Yeah, this is a bit larger.
yeah. This is much better.
All right. So what I did was basically follow the steps that are given in the in the course. That was quite nice of the course designers to to include some hints for okay, maybe it's handy to get certain function calls. The functions, by the way, I had to type in this script. It's quite long. Uh, But so first you make all the functions, then you can use that in your bash, this bash script. So I first can get all the ranges or the distances that are measured by the sensors. And in practice, you only use the front one, the front left, and the front right. So then I set some threshold and some turn duration. And maybe I could have set some more variables here to make it easier to program and to maintain, of course, but I did not. And then I actually built all these if statements. And it was quite a hassle because apparently Linux doesn't do math by itself. So you have to first do some echo, which is like a log, and then pass this resulting string into some math package, which is this part, and then you can actually do this comparison between threshold and front left range. And then I set some integer and like a Boolean, and I did echo left lower than threshold. Actually, so to make sure that I knew when debugging what was happening and if all the logic was correct, right? So all the comparisons are being logged with the echo and are designed in a similar way.
So can you? So let's go back to the functions that you say was a bit of a hassle. So what happens if you just implement the comparison without having to use the pipe BC stroke L? What happens? Did you try that?
Yeah. So I thought I could.
Yeah, if you completely eliminate
easier,
that part. Yeah.
But so if I eliminate this, then this is not an if statement anymore, I think. So then it will say echo this, but then you only have a string, right? The result of this echo is only a string, so it doesn't do anything for this if statement.
Okay.
So then this string has to be interpreted by this part.
Right.
And that results, I think, a Boolean.
Okay, so there are two things that are happening there, but I also want to probe your understanding a bit. So if you eliminate the stroke L, did you manage a better result? Did you get anything better?
Sorry, if I eliminate what?
Stroke L or the minus L that's after BC.
Oh, no, I did not try that, actually.
So if you did not try that, what is the purpose of that?
I don't really know. I thought this was to call the math package in Linux. I kind of assumed that.
Yeah, it's doing a number of things, right? That's why I'm also trying to get you to understand what it's doing, or to try and probe your understanding.
Yeah, so I don't know exactly what each of these letters does. I know that this is done. This is like a math, like this one. This is the one that can compare the interpret
that's the
string
basic calculator. Yes.
And
right.
Yeah, it's basically calculator. That is the BC.
Yeah.
Yeah. Oh, that makes sense. Yeah. Okay.
But then there is a very important aspect with respect to that flag that you see after. All right, and it's part of the one most important thing about using base scripts. So,
okay, so can you tell me about it, because I don't know it.
Yeah, okay. No. So when you use basic calculator on its own, right? Clearly, this is gonna be off your work, but we might bit. Right, when you use basic calculator on its own, you're working with integer values, right? But if you want to work with floating point values, then you have to specify by using the stroke L to allow that calculator to work with floating point values. So values that have got.
Oh yeah. Yeah. Now
something, you know.
yeah. I think I kind of searched for that, but it's been quite some time since I completed this.
All right.
So at first I guess it didn't work, and then yeah, and then I asked our colleague Chat why it didn't work, and then he said, okay, maybe you have to add this if it's floating point. Yeah, yeah.
Yeah. All right. All right. So besides this, what other issues did you run into when you're trying to e- at least have the robot exhibit the behavior that you're getting right now?
So there's like this was kind of the uh, easy part, I guess. I found closing all the if statements with a phi that was very new to me. So I first ran also into that problem, like how does this phi? Why does this phi? Why is it there? When should I use it? And yeah, so this part was also quite new because first I was comparing integers, but that doesn't work. So we should compare actually floating points. What else did I have trouble with?
Okay. So
Um,
I'm also looking at you in more detail as your script as you screw up, right? I want to understand when your robot makes a decision to avoid an obstacle, does it have a preference, right? Does it always prefer
um,
based on your implementation, right? So I want to see when you implemented this, what did you have in mind?
yeah, so basically I used the green text was already there, I think. Um, so I guess it compares also sometimes the left and the right, what it does here, and then so if the left distance from the wall is greater than the right, then it should turn left, and otherwise turn right actually. So that's what it does, and then it sleeps for turn duration. Um, Yeah, so I think I programmed more turning right than turning left, so it has a preference of turning right.
Okay, all right, all right. So let's go a bit down to the bottom. How
Okay.
many cases are you considering in when it navigates, when it's trying to avoid an obstacle?
Yeah, so I think there are eight eight cases. So
If you say you think, right, it doesn't paint a very good picture, right? It's like, well, I think it does 8 things instead of maybe 6 or 4. So
okay,
clearly
so we
you have
can
an
count.
architecture that you're trying to
Yeah, so of course we can count the different cases. So I guess here is like two cases.
if you
Then
okay,
there's a third one.
let's say you're not counting. We want to see the blueprint as it appears in your head, right? What indexes is the robot considering in order to avoid an obstacle or in order to go around something?
Okay, what indexes?
Mm.
So let's say that so we start with these statements, right?
Mm-hmm.
Left, front, and right.
Mm-hmm.
There's like every uh, every combination of these three
Mm-hmm.
is a case, at
Okay.
least.
Okay.
And then there's also ones where it has to decide whether to go left or right because both are free.
Mm-hmm.
No, both are locked, I guess. And then you have to make a choice. And
Okay.
then it compares the two, the left and right sensor.
Mm.
And then based on that, it decides to turn left or right. So that's maybe another 2 extra cases. So yeah, maybe 2 or 3 extra cases. I'm not really sure, but something like that. Um, I
Oh.
did not spell it, write it out. Let's say no.
Okay. All right. All right. Let's speak about more Linux questions, right? So, if you could open your terminal, right? I want us to speak a bit about the scripts that are available and also to
Oh,
get a bit more
I think
detail on how you.
my session has ended,
Yeah.
right?
Okay. Yes. No worries. That's the real
So
robot. So we are defaulting to
yeah,
simulation right now. So
yeah. So, but my terminal should be on my default one, I think. Okay,
mm-hmm.
yeah. So there
Yeah.
it is.
Okay. So if you could get into the directory where you have your base scripts,
Yeah, yeah.
how would
Because,
you? Okay. It's part of. I want to know how would you do it in the terminal, right? So
oh
yes,
yeah. So
without
then
having
I
to
would.
use that.
So I would do this, and I would have to know that when I the uh, did I do a typo?
Yeah, I think there was.
Oh,
Instead
Linus,
of
it
yes.
says. And then I have
Let's
to
get
go
into the
into
Linux
again, I
basics
think.
project. Yes.
And this is the one where
All
I
right.
was. Yeah.
So we have got files that appear green. Let's say that, right?
Yeah,
Well,
yeah.
what that means is that those files are executable, right? Or they've been given permission to execute.
Mm-hmm.
Can you create a file for me and give it permission to execute, whether bash file or any other file?
Cool. Yeah. I think that will be touch test dash. Should have, yeah, and then I should have change mod, something like this. Something. Oh no, I have to provide the script, of course. Oh,
I
that's
think
not it.
yes.
That's not it. Mm,
You're on the right track. I think you are
yeah.
just swapping things around.
Oh, should it be like this? Or dash X, right?
No.
Oh,
Right.
okay.
Okay, no worries. I think let's talk a bit more about something completely different. So, if we're gonna list all the Linux processes that your current machine is running, or this
Mm.
virtual machine, how would you do it?
Yeah. Which processes are running right
Mm-hmm.
now?
Mm-hmm. Yes.
Ooh. That one I don't know by heart, but I would Google it.
All
uh,
right.
yeah,
Yeah.
yeah,
So,
yeah.
okay, I'm
So
looking for these things because you are saying you have done Linux basics for robotics, right? It's part of the things you
yeah,
have to look for to show
yeah,
competency
yeah,
for this.
yeah, yeah.
Right.
So I've seen this. I've seen this command. Yeah, yeah.
Yeah.
I know that I can do it.
All right, all right. So just hang on. We'll wrap it up here, and then we'll speak on Zoom. All right.
Sorry.
All right. So we're gonna wrap it up here. So just hang
Oh
on
yeah.
for me, okay? All right, everyone. This was Rens' presentation, and would like to encourage all those of you who would like to try the same course to do so, and then you can also come and showcase your work. And until next time, keep pushing your ROS learning.